This is Group 45, also known as the Jetsons, and our project was to build a hovercraft. In this presentation, we will discuss our goal, which was to build a hovercraft in under $40, our design process, and the results of building our hovercraft. The goal of our project was to build a working hovercraft for under $40. The hovercraft must be able to navigate throughout all of the course, and the steering must be self-contained. In the first part of our engineering design cycle, our group asked, how can we build a working hovercraft in under $40? We imagined using a small box, 2 fans, and rudders to steer. We decided to create our first product based on the ideas we expressed in our milestone. We decided that using computer fans for our product was the best idea based on other videos of working hovercraft projects we had seen.
Materials that we've bought, we've managed to get this to hover, but it doesn't support any weight hardly. It won't even support the power source.
It vaguely supports it.
And the fan we would originally use for pellet turns out doesn't have any power whatsoever. So it's basically useless. But we can't return it since we've tampered with it, so
we're basically at or a little bit above budget.
Yeah.
But we're just gonna have to work with what we've got and try and figure something out between now and FEDD, which isn't that far away.
In order to improve our project, we decided to scrap the fan that was going to be used to propel the hovercraft. We also attempted to modify the RC car in an attempt to find new ideas for steering the vehicle. In part 2 of our engineering design cycle, our group asked, how can we get the propeller and the steering mechanisms to work without spending hardly any more money? We imagined using a model airplane propeller. This is supported by the fact that RC airplanes fly, and we knew that we also needed a lighter power source. Next, our group planned to create a tower to hold the propeller. We also wanted to try LiPo batteries for power and position the car on the front end of the craft for steering. We glued down the tower and screwed in the propeller and placed the car to the front of the craft so that it was still attached to the craft but could steer. With this second product, some of the improvements that we found still needed to be made were that the batteries were not strong enough. We needed to use AA batteries. The front end also did not lift well because weight was still an issue. In part 3 of the engineering design cycle, our group asked, how can we use AA batteries without weighing down the cart, as well as to ensure that the cart moved forward and had successful steering? We imagined using an RC car to carry the batteries and attach it to the hovercraft to pull it forward and carry the weight. Next, our group planned to tie the car to the craft with extra wire. We taped the battery pack to the top of the car, and these plans proved successful. For our team's final design, we used a computer fan to inflate the hovercraft. We had a model plane propeller and an RC car attached to the craft to steer.
Alright, this is our final design. So we got the propeller, fan, and all the cables are tied up there. They run to here. The batteries are on top of an RC car, which pulls it and turns it. The old design didn't work. We tried to test it. It wouldn't move forward. It was too heavy in the front and wouldn't lift well. So this is what we're going to use, and this is what we're using in the competition.
At FEDD, our hovercraft successfully navigated through the course twice. We managed to place 3rd overall. To summarize everything that our group talked about in this presentation, the goal was to design and build a hovercraft under $40. In our design process, we went through it 3 times and finally created a successful working hovercraft. And the result was that our hovercraft worked perfectly on FEDD day and we got 3rd place.